Hello everyone. The content of this course is Basics of Welding Arc. Mainly include 1. Establishment of welding arc. 2. Establishment and stability of welding arc. 3. Droplet transfer of arc welding. The first part, the establishment of the welding arc. The arc is the welding heat source of arc welding. A conductive process in which charged particles pass through the gas space between the two electrodes, and it is also the most widely used welding heat source at present. From the picture, it can be observed that the arc extends from the end of the electrode to the surface of the workpiece. In general, gas is non-conductive, it is composed of neutral gas molecules or atoms. To make a gas conduct electricity, neutral gas molecules or atoms must be dissociated into charged electrons and positive ions. Moreover, in order to keep the arc burning, the cathode of the arc is required to continuously emit electrons, which must continuously supply electric energy to the arc to supplement the consumption of energy. The arc has the characteristics of low voltage, high current, high temperature and high brightness. In arc welding, gas ionization and cathode electron emission are two basic physical processes that generate charged particles. 1. Ionization. Gas ionization refers to the process of separating neutral gas molecules or atoms into electrons and positive ions under the action of external energy. Ionization voltage. When other conditions are certain, the ionization voltage of a gas reflects the difficulty of generating charged particles in a certain atmosphere. The ionization energy is expressed by voltage. A low ionization voltage means that the ionization of the gas is easier and the arc is relatively stable. According to the different sources of external energy, gas ionization is divided into three forms: thermal ionization, field ionization and photoionization. Thermal ionization refers to the ionization caused by the collision of gas atoms, or molecules, with high kinetic energy at high temperature. Since the temperature of the arc column is generally between 5,000 and 30,000 kelvins, thermal ionization is the main way to generate charged particles in the arc column. Field ionization. The electric field strength of the cathode area and the anode area is very high, up to about 10 to 10 volts per centimeter, and the gas ionization is mainly ionization under the action of the electric field. Photoionization. It refers to the ionization generated by gas atoms, or molecules, absorbing the photon energy of light rays to generate charged particles. 2. Cathode electron emission. The phenomenon that atoms or molecules on the cathode surface receive external energy and release free electrons is called electron emission. The size of the launch capability is expressed in work function. The metal work functions, EV, of commonly used metals and their oxides are given in the table. It can be seen that the work function is relatively low when there is oxide, so electrons easily escape from the oxide film to form cathode spots. According to the different forms of applied energy, electron emission can be divided into four types: thermal emission, field emission, light emission and particle collision emission. But in actual welding, a variety of electron emission mechanisms are often used to complete the task of electron emission. The second part, the structure and stability of the welding arc. 1. The structure of the welding arc is shown in the picture. The arc area consists of three parts, mainly including the cathode area, the anode area and the arc column area. The cathode area is close to the end of the cathode, and the electric field strength is very large, which is the main reason for the field emission. The anode area is close to the anode, and the arc column area is a section between the cathode area and the anode area, and its length is much larger than that of the cathode area and the anode area, accounting for most of the arc length. The stability of the welding arc refers to whether the arc voltage and welding current can be kept relatively stable, and at the same time, it must maintain a certain arc length, not blowing, not swinging, and not extinguished. Whether the arc combustion is stable or not has a great influence on the welding quality, which also affects the quality of the product. In addition to the proficiency of the operator, the stability of the arc is not only related to the proficiency of the operator, but also factors that affect the stability of the arc include welding power source, electrode coating, airflow, unclean welding, and magnetic deflection of the arc. Welding power source. The type and polarity of the welding power source will affect the stability of the arc. The DC power supply is more stable than the AC power supply. The welding power supply with higher no-load voltage has more stable arc combustion than the power supply with low no-load voltage. And the welding machine with good dynamic characteristics is easy to keep the arc burning steadily. Electrode coating. The more substances with lower ionization potential, such as potassium, sodium and calcium oxides, in the electrode coating, the better the gas ionization degree, the stronger the conductivity, and the more stable the arc combustion. Airflow. When arc welding is performed in an open-air environment, wind blowing has a great influence on the stability of the arc, and even welding cannot be performed in severe cases. The welding place is not clean. If there is grease, moisture, rust, etc. in the welding place, they will absorb heat and decompose during welding, thus reducing the heat energy of the arc and affecting the stable combustion of the arc. Magnetic deflection of the arc. Under normal conditions, the axis of the arc is consistent with the axis of the electrode, but sometimes it is found that the arc deviates from the center line of the electrode. This is due to the distribution of magnetic lines of force on both sides of the electrode when using DC welding. Height is uneven, so the force is unbalanced, and the arc is biased to the side with the smaller magnetic flux density, which is the magnetic bias blow. The arc blowing also reduces the stability of the arc combustion. When the magnetic bias blow is generated, the angle of the wire can be changed, and the electrode can be tilted in the opposite direction to the bias blow, thereby reducing the magnetic bias blow. The third part, the droplet transfer of arc welding. Under the action of arc heat, the molten metal at the end of the welding wire or electrode forms a droplet, which is detached from the end of the welding wire and transferred to the molten pool under the action of various forces. The forces subjected to the droplet transition include gravity, surface tension, electromagnetic force, droplet blasting force, the gas blowing force of the arc, and spot pressure. 1. Gravity. When the diameter of the welding wire is large and the welding current is small, in the case of the flat welding position, the force that makes the droplet detach from the welding wire is mainly gravity. 2. Surface tension. Surface tension is the main force to keep the droplet on the end of the wire. During flat welding, surface tension hinders the transfer of the droplet, so as long as the surface tension is reduced, it will be beneficial to the droplet during flat welding. 3. Electromagnetic force. When the current flows through the conductor, a magnetic field is generated around the conductor, and the magnetic field produces a compressive force on the conductor, which becomes an electromagnetic force. The direction of the electromagnetic force is perpendicular to the surface of the conductor. When welding is performed at any position in space, the electromagnetic force has the effect of promoting the transfer of droplets. When welding with a large current, the main force of the droplet transfer is the electromagnetic force. 4. Droplet blasting force. When the inside of the droplet generates gas or contains evaporable metal due to metallurgical reaction, the accumulated gas will expand under the action of high temperature of the arc, and a large internal pressure will be generated, resulting in the explosion of the droplet. This internal pressure it is called the droplet blasting force. 5. The gas blowing force of the arc. No matter what position of welding, the arc gas blowing force always promotes the droplet transfer. 6. Spot pressure. When the spot area is small, the spot pressure is often the force that hinders the transfer of the droplet, and when the spot area is large and covers the entire droplet, the spot pressure often promotes the transfer of the droplet. The form of droplet transfer melting electrode arc welding droplet transition forms include short circuit transition, Coanda transition, jet transition, explosion transition, and granular transition. 1. Short circuit transition. During short arc welding, the growth of the droplet is limited by the arc space and has the characteristics of short arc length, small current, and thin wire, such as CO2 welding, electrode arc welding, overhead welding. 2. Coanda transition, such as submerged arc welding, electrode arc welding. 3. Jet transition, small droplets, fast frequency, stable transition, small splash, large penetration, and beautiful forming, such as MIG welding. 4. Explosive transition, the least desirable. 5. Granular transition. Coarse granular transition is not smooth. Fine granular transition is relatively smooth. Students, this is the end of this lesson. Thank you for watching.